The next thing we need to do is to make the sheep move. Now, with the ECS, it's not actually intuitive how the sheep move because you actually make a script called a job component system, and just by the fact that it exists in the assets folder, it will run. So you don't actually attach it to anything, which seems a bit odd at first when you're used to using Unity the way it is. So let's go ahead and create another C# script. We're going to call this the move system, and let's open that up. Now the move system needs a whole bunch of libraries at the top. So we want the Unity engine, then we want our entity. So using unity.entity or entities, using unity.mathematics, using unity.transforms, and using unity.jobs. So in here we are actually creating our job system, but the structure of it is a little bit different in the way that we program it, even though it's going to essentially do the parallel processing of a for loop like we did before. Now, instead of a mono behavior, it's actually a job component system. And it doesn't have an update or a start. Now, this system needs to have, and you're getting an error there because we actually haven't implemented it, a method for onUpdate. Okay, so in here, let's go protected, override, job handle, onUpdate, job handle, input dependencies, okay, or input deps for short. Now the dependencies are things that this job can't do or can't start unless these other jobs have actually finished. In this case, we don't have any other jobs. We only have this one job that we're creating, and it has to return a job handle, which we haven't created yet, not the declaration of it, but an actual job handle. So our var job handle is going to equal entities dot with name, and the name is move system. So what this with name does is puts all of your entities into something called move system. So I guess you can kind of group them and access them later. Now from that we have another dot for each. Now this for each is actually rather clever. You give it all the component data and it goes and finds the entities that exist in the system that have that component data. So you're not actually having to pass anything to here, it's just doing it for you. So the first thing will be a ref to our translation, which of course is position, and we're just calling it position, and then another ref for rotation, which is rotation, and another bracket. Now we've got two brackets here at the beginning and one at the end because we're actually still inside of this for each declaration or method, I guess. And we're going to put an equals and then a greater than sign because we're going to declare what's inside of it. So a little bit of different syntax again if you're not used to using squiggly brackets in this way inside of things. Now inside of our for each is where the movement stuff is going to happen. So again, we're attempting to do exactly the same thing as we've done like several times before. Now it was different in the classic game objects to move those. It was different again in your basic classic parallel job system, and guess what, it's different again in this job component system in the ECS. So it's going to be position dot value. So remember that we set this position, which is our translation structure, and the value that's sitting inside of that is the actual position, so it's a float 3. Now we're going to do a plus equals on that. Again, we want 0.1f. Remember, that's basically our speed, I guess. It's not really a speed, but it's how much we're changing each loop to move these things forward. Now, we've used rotation in the past to make sure that we're actually pushing this along its z-axis. In this case, we have to multiply by math.forward of our rotation.value, which is essentially getting exactly the same vector of 0, 0, 1 that we've been using. But I guess it's more of like a quaternion type value. So the math does look a little bit different. But what we've now done is moved the position of a sheep forward by 0.1. Okay, what do we do in every other situation that we've done? Okay, we open if position.value.z is greater than 50, then we go and set position.value.z to equal minus 50 to move our object back down the bottom of the screen. Okay, so that's finishing the interior of our for each. We then need a bracket to completely finish that. Then we're going to schedule it. So you can see we're doing a whole bunch of stuff here in this same statement, which is a little bit of reminiscent of JavaScript. If you've done any JavaScript programming and you're used to declaring methods and functions inside of other functions and function pointers and things like that, this might look a little bit familiar to you. And now we want to schedule, and we're going to schedule according to our input dependencies, which get passed through, which are basically pretty much nothing, I guess, in this case. Then we return our job handle. So that is your job component system, move system, and this here is basically the little bit of math that we've been constantly doing over and over again with everything. Right, so save that, and now we don't actually have to put it anywhere. Okay, again, as I said, it's a bit strange because you usually have to stick a script onto a game object. Let's press play. We should now see that our sheep start to move. Okay, great. So our sheep are moving and we've got like 123 frames per second with those sheep. So isn't that great? Isn't that amazing? You can see now how much we have increased that 15,000 lot of sheep to be moving pretty much the same way in each example, but going from the classic example, which was about, 22 frames per second, we're now sitting at 120 frames per second. So that is the power of the ECS and of the DOTS architecture. So by using those component systems. Now, if you take a look at your program when it stops running, you'll notice that you get this really odd error down the bottom saying that there's a native array that has been deallocated and that you're not allowed to access it. The problem here is that there's script running that shouldn't be running. And it's actually coming from your spawn manager that has your ECS manager script on it. The error, if we go down and investigate in the console and click on it, if you have a look, it says that it's coming from onDestroy in spawn parallel script. Now this is the script here up sitting on your spawn manager, and it's not even turned on, but for some reason that onDestroy is still working. Now this could be a bug in Unity, I'm not quite sure, but just to make sure in the future as we do continue on is that these scripts, we have left them hanging around because we were using them from comparisons and all that type of thing, but it's probably just worth clicking on them and actually removing them completely. And then if we run again, which should clear that error, and then stop running, you'll find that we no longer getting that problem. So that's just going to clean it up. Now, obviously that code is running if it's going to be causing an error and it could interfere with things in the future. So I guess it is good that we just kind of remove it rather than leaving it there and turned off, because obviously it's not turned off. Okay, so you're done. You've created your very first ECS program with moving sheep in it. Okay, so at this point you've got like 120 odd frames per second, depending on the machine that you're on, with 15,000 sheep. So now it's time to actually play around with the number of sheep, and you can change that with your constant int value for num sheep. Have a go and turn it up and see how high you can get to actually push this frames per second back down to like 20 frames per second, which is what we started with. And then you'll be able to see just how many more game objects or sheep mesh we're able to deal with through using the dots architecture.